In this video, let's have a look at interpreting graphs and tables. Just a bit of a recap, some key ideas of what you're expected to know before this section. Types of data. There is a separate video on this if you need some refresher on it. If you get asked what type of data a set of data is, you ask yourself, does it involve numbers or categories? So if it's categorical or numerical. If it involves numbers, then there's two types within that. It could be discrete, which is countable things, or continuous numerical data, which is measured data. Categorical data within that, you can have nominal or ordinal, so it might involve numbered categories or ordered categories. Again, if you're not sure, go find the other video. And a refresher about the different types of graphs that we could have. So column graphs here, sometimes you'll see them called histograms. Sometimes column graphs have gaps in between. Sometimes they're next to each other. Sometimes they touch the vertical y-axis and sometimes not. It will depend on your data. What's this one called? We call that a pie chart or a pie graph, sometimes sector graphs, and that the whole thing represents 100%. We might have a divided bar graph here. And then these are both called line graphs because they both involve straight lines. But this one we call a linear graph. Notice that the word linear has line in it. And the difference between these two, technically what's happening here is the rate of change between all of the points on the graph is the same. So this is a true linear graph. And this one here, although there's straight line sections, they change from time to time. So that we call that one non-linear. So for these questions, first one, the column graph represents the annual income of 5 different people. Let's take a moment just to look at the graph that we're asked to describe. On our horizontal axis, we've got 5 people. And on the vertical y-axis, we have their income in dollars. Notice that that's going up in $20,000 each time. Part A, what is a Reuven's annual income? Let's find a Reuven on the graph. That's the blue column. We read up to the top of the blue column across to the vertical y-axis and we have $60,000. So for what is a Reuven's annual income, we would write $60,000. I have put that little comma in there. Sometimes we do that in maths to separate groups of 3 numbers, but you don't have to. Part B, what is the difference between Jamie's income and Ashdev's income? So let's have a look over here first. Where is Jamie? That's the tall green column. And Ashdev, the shorter red column. And what does difference mean in maths? What operation do we need to do? A subtract. So you need to do the biggest number, subtract the smallest number. Which is the biggest number out of these two? The green one. So let's read up and see how much that is. It's between the 2 blue lines. We're assuming it's about halfway between. So halfway between 80 and 100,000 would be 90,000 for Jamie. So what's the difference between Jamie and Ashdev's? $90,000 for Jamie. Ashdev, reading up and across, $40,000. And the difference between those two is $50,000. Again, you can put the comma in or not. It doesn't matter. Okay, who earns the most? Who, we're after a person, and the most, the tallest column. Over here, the purple column is the tallest. And who does that belong to? Stefan or Stefan. I think it's a good technique that when you're asked a question in a sentence, it's a good technique to practice writing the answer in a sentence. Who earns the most? Stefan earns the most. Second question. A car owner graphs the amount of money spent per year on car-related expenses. So let's have a look here of our pie chart. These are all the different costs that you might spend if you own a car. About that much is petrol. How much of the graph would you say that is? Half or 50%. Then we have maintenance here, which would be things like a service, maybe tyres, registration to make sure your car's registered, and insurance. So part A, what is the largest expense each year? Well, which section fills up the most of the pie chart? Petrol. So part A, what is the largest expense each year? We could write petrol. Part B, what percentage of the car's expenses is devoted to maintenance? So let's find maintenance and what percentage. So the whole pie graph would be what percent? 100%. And petrol takes up half or 50%? And what fraction there do you think maintenance is? It looks like it's a quarter of the pie chart, and a quarter as a percentage though, it is 1/4 of 100, and that would be 25%. Have we answered the question? What percentage of the car's expenses is devoted to maintenance? 25%. Good. And part C, if the car owner spends $3,000 per year on petrol, what is the total amount spent on the car each year? So if that portion of the graph is 3,000, what would this portion be to make up the total amount? I'm sure you can already anticipate that. But how would you write that out? Basically, as maths teachers, we want to see what's going on in your brain. We want to see how you think. So one way you might think of that is, well, 50% is $3,000. And we're interested in 100% of the graph. Well, how do you turn 50% into 100%? What operation would you have to do to that? You would multiply by 2, which means then you have to take the $3,000 and multiply that by 2 as well to give you a number of 6,000. So the question, what's the total amount spent on the car each year? $6,000. We should write that as a sentence. Running out of room there. $6,000 is the total amount. That's that question. And last one, not a question so much, but just something to be aware of. Looking at this graph here, you might notice something different on this vertical axis. We call that a broken scale. Have a think about why. If you had to graph these numbers, noticing that most of these numbers are between the 0.7, 0.8, 0.9. So if you were to draw a graph and these were going up by 0.1s, you would have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 8, and 9. Most of the values lie in this region. And so sometimes when we draw these graphs, we don't really want most of what's happening down here. So we sometimes put what could be called train tracks in, that's showing that you've broken the scale, or sometimes it's a squiggly line as you're drawing the graph to show that you're the reader, that you know that there's actually numbers that are in here, but we don't need to show them for now. Okay, so that video is on interpreting graphs and tables.